Welcome to Astronomy Daily, where we explore the vast frontiers of our universe and bring you the latest developments in space science and astronomical discoveries. And I know you were probably expecting to hear from Steve and Hallie today, but unfortunately Steve has become a little busy and needs the day off, and consequently Hallie decided she'd do the same. So I'm your host instead. My name is Anna, and I'm excited to share today's cosmic journey with you. We've got an incredible lineup of stories that highlight just how remarkable our quest to understand the universe truly is. From the microscopic to the massive, from nearby space stations to distant exoplanets, today's episode spans the full spectrum of space exploration. So buckle up for a journey through the latest wonders and debates in astronomy and space exploration. In what might be one of the most intriguing discoveries in astrobiology this year, scientists have identified a completely new bacterium aboard China's Tiangong space station. This microscopic organism, which has been named Nyalia Tiangongensis, has never been documented on Earth before, raising fascinating questions about microbial adaptation and evolution in space environments. The discovery came through work led by Dr. Zhongxia Yuan from the Shenzhou Space Biotechnology Group in Beijing. Following detailed genetic and biochemical analysis of samples collected as part of the China Space Station Habitation Area Microbiome Program, or CHAMP, researchers confirmed they were dealing with an entirely new species. What makes this tiny hitchhiker particularly interesting is how well suited it appears to be for life in orbit. The bacterium is rod-shaped and microscopic, but its most notable feature is its ability to form spores-resilient structures that help certain microorganisms survive harsh conditions. This adaptation may be crucial for enduring the extreme radiation and microgravity environment hundreds of miles above Earth's surface. The researchers also noted that Nyalia Tiangongensis breaks down gelatin in a distinctive way, which could be an important survival mechanism in the nutrient-limited environment of a space station. This ability to efficiently process available resources might explain how the microbe has managed to thrive in such an isolated ecosystem. Space stations are essentially sealed habitats containing people, equipment, and countless microorganisms. Many of these microbes originate from crew members or cargo, making it challenging to determine whether this bacterium was a stowaway from Earth that developed new traits, or if it somehow evolved in response to the unique conditions of space. Experts studying microbial behavior in orbit have previously observed how certain species can form biofilms, structured communities that increase resistance to environmental stressors. A NASA study on the International Space Station demonstrated that some microbes can develop heightened tolerance to the elevated radiation levels encountered in low Earth orbit. The new bacterium appears to be related to Nyalia circulans, a known Earth microbe that can cause sepsis in people with compromised immune systems. However, it remains unclear whether this space station variant carries similar health risks or has acquired new properties that might affect its interaction with humans. This discovery underscores just how little we know about the vast array of microorganisms around us. While tens of thousands of bacterial species have been cataloged, billions more remain unidentified. The emergence of this space-adapted bacterium serves as a reminder that life finds extraordinary ways to adapt to even the most extreme environments humans create. Next up, an update to a story we brought you some weeks ago. A scientific debate is heating up in the astronomy community over what would have been groundbreaking news: potential signs of life on an exoplanet. In 2023, a team from Cambridge University announced that NASA's James Webb Space Telescope had detected what appeared to be evidence of a liquid water ocean on K218b, a temperate sub-Neptune world about 124 light-years from Earth. Earlier this year, the same researchers doubled down on their claims, suggesting they had found even stronger evidence for possible alien life. The excitement centered around a tentative detection of dimethyl sulfide, or DMS, a molecule that on Earth is produced exclusively by marine organisms. They also potentially identified DMDS, a close chemical relative that could similarly indicate biological processes. Combined with the possibility that K218b is what scientists call a Hycean world, a planet with a hydrogen-rich atmosphere above a liquid water ocean, these findings generated tremendous media attention and speculation about the first potential detection of alien life. However, independent research teams have been conducting their own analyses, and the results are casting significant doubt on these claims. A new study led by Raphael Luke from the University of Chicago has re-examined the original data using a more comprehensive approach. Rather than analyzing data from each of Webb's instruments separately, Luke's team conducted a joint analysis using information from all three of the telescope's key instruments simultaneously. This approach ensures that scientists aren't telling what Luke's colleague Michael Jang calls contradictory stories about the same planet. When analyzing the combined dataset, the researchers found that the signal for DMS or DMDS was much weaker than originally reported, so weak, in fact, that they described it as statistically insignificant. As team member Caroline Piolet-Gorayeb explained, "We never saw more than insignificant hints of either DMS or DMDS, and even these hints were not present in all data reductions." Their work suggests that the spectral features observed could be explained by other molecules commonly found in exoplanet atmospheres that aren't associated with life. This controversy highlights a fundamental challenge in the search for extraterrestrial life. The chemical signatures of potential biosignatures like DMS are incredibly subtle and can be easily confused with more common molecules. For instance, the difference between DMS and ethane, a common non-biological molecule in planetary atmospheres, is just one sulfur atom. While the Webb telescope represents a quantum leap in our observational capabilities, distinguishing between molecules with such similar structures remains extremely difficult, especially across distances measured in light years. As Piolet-Gorayeb noted, until we can separate these signals more clearly, we have to be especially careful not to misinterpret them as signs of life. Okay, moving on to something a little more positive. Have you ever wondered how the light from stars billions of light years away manages to reach us without dimming into nothingness? This remarkable property of light was beautifully illustrated by an astrophysicist who captured images of the Pinwheel Galaxy from his San Diego backyard. When his wife asked if light gets tired during its 25 million year journey across 150 quintillion miles of space, it sparked a fascinating exploration of light's extraordinary nature. Light is fundamentally different from anything we encounter in our everyday lives. As electromagnetic radiation, it consists of coupled electric and magnetic waves traveling through space-time. What makes light truly special is that it has no mass whatsoever. This seemingly simple characteristic has profound implications for how light behaves across cosmic distances. Because light is massless, it's not constrained by the limitations that affect physical objects. While everything with mass can only approach but never reach light speed, light itself travels at the universe's ultimate speed limit, approximately 186,000 miles per second, or nearly 6 trillion miles per year. To put this incredible velocity into perspective, a single particle of light can circle our entire planet more than twice in the blink of an eye. When light travels unimpeded through the vacuum of space, it maintains this tremendous speed indefinitely without losing energy. This is counterintuitive to our everyday experience, where moving objects eventually slow down due to friction or other forces. But in the vast emptiness between stars and galaxies, there's simply nothing to slow light down. That's not to say that all light reaches us intact. Some photons do collide with interstellar dust particles or gas clouds along their journey, causing them to scatter or be absorbed. This is why distant celestial objects can appear dimmer or redder than they actually are, a phenomenon astronomers call extinction. However, the vast majority of photons travel through the nearly perfect vacuum of space without encountering any obstacles whatsoever. This ability to maintain energy over immense distances is directly tied to Einstein's theory of relativity. According to this revolutionary framework, time itself behaves differently depending on your speed and proximity to gravitational fields. For objects moving at extreme velocities, time actually slows down, a phenomenon called time dilation that has been repeatedly confirmed through precision experiments. For light, this time dilation reaches its theoretical maximum. If you could somehow ride alongside a photon, impossible since you have mass, you would experience something truly mind-bending. From your perspective, time would completely stop. Meanwhile, space in your direction of travel would appear compressed to nothing. What we perceive as a journey of millions or billions of years would, from the photon's frame of reference, happen instantaneously. This peculiar relationship between light and space-time explains how photons can travel such tremendous distances without degradation. From the photon's perspective, there is no journey at all, just instantaneous transport from source to destination. Now imagine yourself as a photon, a massless particle of light traveling at the universe's speed limit. From your perspective, something truly extraordinary happens. Time completely stops. This isn't science fiction. It's a direct consequence of Einstein's theory of relativity that fundamentally changes how we must think about cosmic journeys. When we observe light from distant galaxies, we calculate travel times in the millions or billions of years. The photons reaching Earth from the Pinwheel Galaxy, for instance, have been traveling for 25 million years according to our Earthbound clocks. But for the photon itself, this immense journey happens in an instant. Literally no time passes from its perspective. This mind-bending reality occurs because as an object approaches the speed of light, time dilation becomes more pronounced. At exactly light speed, time dilation reaches its absolute maximum. If you could somehow attach a clock to a photon, which is physically impossible, that clock would never tick forward. The moment of emission and the moment of absorption would be the same moment. Even more strange is what happens to space from the photon's perspective. As velocity increases, space itself contracts in the direction of travel. For a photon moving at light speed, this contraction becomes complete. The entire distance between source and destination essentially shrinks to zero. So while we see vast gulfs of space separating cosmic objects from the photon's viewpoint, there is no separation at all. The star that emitted it and the telescope that detected it might be separated by billions of light years in our reference frame, but to the photon, they occupy the same point in space-time. This reveals something profound about the nature of our universe. The cosmic speed limit isn't just an arbitrary rule, it's woven into the fabric of reality itself. As objects approach this limit, the very concepts of time and distance transform in ways that preserve the consistency of physical laws throughout the universe. Next on our agenda today, a UK-based space propulsion startup called Pulsar Fusion has recently unveiled an ambitious concept that could revolutionize our approach to interplanetary travel. Their Sunbird migratory transfer vehicle represents a dramatic leap forward in space propulsion technology, powered by what they call dual direct fusion drive engines, or DDFD for short. What makes this concept truly revolutionary is the projected speed. According to Pulsar Fusion, the Sunbird could achieve velocities of up to 329,000 miles per hour. To put that in perspective, that's over 150 times faster than the International Space Station's orbital speed. If these projections hold true, the Sunbird would become the fastest self-propelled object ever engineered by humans. The key to this extraordinary performance is nuclear fusion, the same process that powers our sun and other stars. Unlike conventional chemical rockets that have fundamental limitations on exhaust velocity, these fusion engines could produce exhaust speeds of approximately 310 miles per second, or about 500 kilometers per second. This represents a quantum leap beyond current propulsion capabilities. In a demonstration video, the company shows the Sunbird undocking from a space station, carefully maneuvering with 8 thrusters to attach to a larger spacecraft resembling a SpaceX Starship upper stage, before igniting its main engines and accelerating toward distant planets. Of course, significant engineering challenges remain before this concept becomes reality. Pulsar Fusion acknowledges they're still in development, with plans to demonstrate essential components of the fusion power system later this year. They've set an ambitious target of 2027 for full in-orbit testing, a timeline that would mark a historic achievement in both aerospace engineering and energy technology if successful. The implications for Mars exploration are particularly exciting. Current chemical propulsion systems require lengthy transit times to reach the red planet, typically 6 to 9 months depending on planetary alignment. A fusion-powered vehicle could potentially cut this journey time dramatically, making Mars missions more feasible from both human factors and logistical perspectives. Beyond Mars, the technology could enable more rapid exploration throughout the solar system. Missions to the outer planets that currently take years could be accomplished in months, opening new possibilities for scientific discovery and potentially even resource utilization beyond Earth. What Pulsar Fusion is proposing isn't just an incremental improvement. It represents a fundamental shift in our capability to traverse the solar system, potentially transforming interplanetary space from a forbidding frontier into something more akin to a navigable ocean with established shipping lanes and regular traffic. The versatility of the system appears to be a key selling point. Pulsar Fusion envisions their technology powering missions ranging from deploying telescopes in deep space to transporting robotic probes throughout the solar system. As commercial interest in lunar and Martian resources continues to grow, having a reliable, relatively affordable transport system could accelerate development beyond Earth orbit. What's particularly interesting about this approach is how it mirrors historical patterns of transportation economics. Just as shipping containers revolutionized global trade by standardizing cargo transport, these fusion-powered spacecraft could create a standardized approach to moving materials beyond Earth. The establishment of regular shipping lanes between Earth, lunar colonies, Mars outposts, and even asteroid mining operations could create entirely new economic opportunities. Finally today, I love this. In a beautiful intersection of classical music and space exploration, Johann Strauss's iconic composition, The Blue Danube, will soon be traveling among the stars. This month, to commemorate the 200th anniversary of the Austrian composer's birth, his famous waltz will be beamed into the cosmos in a special transmission organized by the European Space Agency. The celestial performance will feature the Vienna Symphony Orchestra, with their rendition of the beloved waltz being converted into radio signals and transmitted from Earth on May 31st. This cosmic concert also serves as a celebration of the European Space Agency's 50th anniversary, creating a meaningful connection between artistic heritage and scientific achievement. While the performance will be live-streamed with public screenings in Vienna, Madrid, and New York, ESA is taking no chances with the actual space transmission. They'll relay a pre-recorded version from the orchestra's rehearsal to ensure technical perfection, while the live orchestral performance provides the earthbound accompaniment. The radio signals carrying Strauss's masterpiece will depart Earth at the speed of light, an astonishing 670 million miles per hour. This means the waltz that once accompanied dancers across European ballrooms will hurtle past our moon in just 1.5 seconds. It's a fitting cosmic journey for a piece that many associate with space, thanks to its memorable appearance in Stanley Kubrick's 2001: A Space Odyssey. The transmission represents something of a correction to a historical oversight. When NASA launched the Voyager probes in 1977 with their famous golden records containing sounds and music of Earth, Strauss's compositions were notably absent, despite their cultural significance. Vienna's tourist board has characterized this transmission as rectifying that cosmic mistake, finally giving the Blue Danube its rightful place among the stars. ESA will use its powerful radio antenna in Spain, part of the agency's deep space network, to transmit the waltz. In a poetic touch, the dish will be pointed toward Voyager 1's location, sending Strauss's music in the direction of humanity's most distant spacecraft. This musical mission joins a tradition of transmitting human artistic achievements into space. In previous years, NASA has beamed the Beatles across the universe and Missy Elliott's The Rain toward distant celestial bodies, while the Mars rover Curiosity even relayed Will.i.am's Reach for the Stars back to Earth from the Red Planet. As ESA Director General Josef Aschbacher noted, music connects us all through time and space in a very particular way. In sending this timeless composition beyond our world, humanity continues its practice of sharing our cultural treasures with the cosmos, a gesture of artistic connection that extends far beyond the boundaries of Earth. The radio signals carrying Strauss's waltz will travel at truly cosmic speeds, racing through our solar system and beyond. After passing the moon in just 1.5 seconds, the beautiful melodies will reach Mars in only 4.5 minutes. Within 37 minutes, Jupiter will hear the waltz, and by the 4-hour mark, the music will have traveled beyond Neptune at the edge of our solar system. Perhaps most remarkably, within just 23 hours, Strauss's composition will have traveled as far from Earth as Voyager 1, humanity's most distant spacecraft currently over 15 billion miles away in interstellar space. Music has even flowed in the opposite direction. In 2012, NASA's Curiosity rover on Mars received Will.i.am's Reach for the Stars and then relayed it back to Earth, creating the first interplanetary musical transmission from another world. Unlike the routine melodies streamed between mission control and orbiting crews since the mid-1960s, these deep space transmissions represent deliberate attempts to share human culture with the cosmos. Whether anyone or anything will ever receive these musical messages remains unknown, but the gesture itself represents humanity's persistent desire to connect across the vastness of space. What a journey we've taken today across the cosmos. From the microscopic to the musical, our exploration reminds us that space science continues to surprise and inspire us in equal measure. The stories we've explored today span from bacterial adaptations to cosmic musical performances, yet they all share a common thread: human curiosity. Our desire to understand, to explore, and to connect across the vastness of space continues to drive us forward into an exciting future among the stars. Thank you for joining me on this cosmic journey. I'm Anna, and this has been Astronomy Daily. For more astronomy and space news, just visit our website at astronomydaily.io. Until next time, keep looking up. There's always something fascinating happening in our universe.